Now I'm going to ask, well, actually this time I can only ask what are the final velocities of both objects. Find V1, V2, and one of their angles. In order to do the totally elastic problem, I'm going to have to give you the angle of the one of them, and then I can ask you find the other 2V, and then the final angle. So the picture looks something like this. After they collide, what's going to happen? The 2 kilogram, now these one elastic, right? They bounce off each other. So what is likely to happen here? Kind of like this maybe, huh? The 2 kilogram probably goes up at a certain velocity, let's call it V1, whose angle we don't know, let's say. And probably the 5 kilogram goes down at a certain velocity, which we don't know, whose angle I'm going to have to give you. I'm going to have to give you one of the angles, because if you can't do it with 4 unknowns. Let's say here 35 degrees. Does that make sense? Yeah, 35? No? We don't know, huh? Okay, so now solve for V1, V2, and theta. I could have given you that angle, and then you would have solved that angle, right? So in this case, what's going to be conserved? Since it's totally elastic, both the momentum is in the x direction and the y direction, plus the kinetic energy of the system is conserved. That's why I'm not asking find percent loss of Ke, you know. So momentum in the x direction equal momentum initial in the x. So momentum final in the x is 2 times V1 times cosine theta. Okay. Now what we could do with this one is we could work with this angle, 35, but just realize that it's negative, right? Because it's in the third quadrant. So I could put in the negative myself. So 2V1 cosine theta minus 5V2 cosine 35. Because the x component of the velocity is negative. So that's P final in the x direction. 2V1 cos theta minus 5V2 cos 35. That's equal to P initial in the x direction, which we had earlier. That's 2 times 3, which is 6. Plus 10 cosine of 132, right? So that's one equation. We're going to end up with 3 equations and 3 unknowns here. This is an algebraic problem here. Got to use algebra. That's the one equation. Then we have P final in the y direction equals P initial in the y direction. Okay, P final in the y direction is 2 times V1 times sine of theta. And then the y velocity of this is also negative. It's in the third quadrant, right? So negative 5 times V2 times sine of 35 is equal to, again, the total initial y momentum, which is 10 times sine of 132. And then that's that. So that's our second equation. And now I need an equation for kinetic energy. Kinetic energy initial equals kinetic energy final. So kinetic energy initial, which we already know, wasn't it 19? 19 joules, right? We already did that in the example 1. So that's 19 joules must equal to the kinetic energy final, half times 2 times V1 squared plus half times 5 times V2 squared here. And remember, the kinetic energy has no direction in it. So now that's it. Here's 3 equations and 3 unknowns. How do we tackle this? How do we tackle this? We've got V1 cos theta. We have V1 sine theta. It looks like a whole lot of mess. I think one of the best ways, of course, eventually the TI is going to come in handy here. But in order to get it to the TI, we need to do some maneuvering around here. We could do yeah, you know what we should do? We should solve for V1 in terms of V2, at least try to come up with some kind of equation from those equations 1 and 2. So we can have something that looks like this. Yeah, we have so I could move the negative 5V2 over to the other side. And I have an equation here where I have V1, divide everything by 2 cosine of theta. So I have V1 is equal to 6 plus 10 cosine of 132 plus this whole thing, again, 5 cosine of 35 times V2 divided by 2 cosine theta. So just take this whole thing, divided by 2 cosine theta, and you just have an equation in terms of V1. It still didn't help too much, right? Because all we did is just move this around. But now what we could do is we could take the V1 and substitute it into this, the second equation, okay? And we've got another mess. So substitute this thing. So I'm putting this where you see the V1 in the second equation, minus 5V2 and now here the 2 and the 2 cancel, and sine of theta over cosine of theta is tangent of theta, right? So that simplifies. So let's write it as tangent of theta. And now I could rearrange this. So now